Hello, this is Shinru. In this video, we are going to take a look at question 687, longest univalue path. In this question, we're given a binary tree and we need to find the length of the longest path, where each node in the path has the same value and this path may or may not pass through the root. The length of the path between two nodes is represented by the number of edges and between them. So, for example, in example 1, so the longest path, the longest path is with the same number of node, 555. So this is the longest path, and the length is represented by the number of edges. Sorry, the number of the edges between them. So you can see there are two edges. So we see it's 2. And now let's look into the example 2. And in example 2, the longest length is 444, and there are two edges, so it's 2. So let's think about how to get this longest path. So to do that, we have to visit every node, and it will be easier if we use if it is a question about every level in the tree, then it will be easier if we use iteration. But if it's a question that requires depth first search, and we need to go through the left node and right node of every tree, of every node, then it will be easier to use recursive. So in this question, we need to run a depth first search to go through the left node and the right node if we need to know the longest path, because we have to check if the subnodes, if the value of one of the subnodes are the same as the root node. So in that case, and in this question, we also need to return the length of the longest path. So to return the length of the longest path, what we can think of is we can create a variable that stores the current length. Then we always update the variable when there's a bigger length. So we can define the variable outside of the function using using closure, because in JavaScript a variable is defined outside of the scope can be used inside of the inner scope. So what we can do is we can first create our result variable outside of our function, or we call it result, and assign it 0. And what we can do next is we can create our function, which will be the depth first search, and always calling the current node. And if current node doesn't exist, we just return 0, and then we call the left node and the right node of the recursive function. So we say L is equals to depth first search of root.left, R is equals to depth first search of root.right. So after that, what we can do is we can check some conditions. So first condition you have to meet when there is a left length can be calculated is that first the left node has to be exist. So the left node has to exist, and the left node's value has to be the same as the root value, and same goes with the right side. So what we can do is can call left length is equals to, so we do a couple of condition check. So first is the root dot left should be exist. That's if the root dot left doesn't exist, then left length doesn't exist. And another thing is root's value, root dot left dot value should be equals to root dot value. So when these two conditions are met, then we can say there's a left length, and the left length will be the current left length plus 1. Otherwise, it will be 0. The left length won't exist because we won't be looking on the left side. And if right length, we do the same with the right length. So the right node has to exist, and the right's value has to be equals to root's value. So if that's the case, the returned value for the root dot right should plus 1, otherwise should be 0. And now we need to do two things. First thing is we need to update our result. So the length so the left length and right length is those. So basically, if you look at this example, so the left length and the right length. So if I add one more 4 here, that will make it more easier. So if you look at this structure, so the left length will be 2 because 4, 4, 4, so it will get 2, and the right length will be 1. So the total length will be 2 plus 1 is 3. So we have to always update the result. So result is the maximum total length. So we need to keep updating it. Result is equals to mass.max of result and the left length plus right length. So we update the result every time when we get the left length and right length. And another thing is we need to return the current longest length, because we will go through that length as the current return value for the right length. So sorry, for the right node. So what we will do is return mass.maximum of the left length and the right length. So we will use those numbers as the current longest current length for the left node and the right node for the current node. So after this, the recursive function, what we need to do is just call the recursive function, and it will start updating the result variable, and eventually we return the result variable. So the key point is to pick a recursive function instead of iteration, because we need to visit every node, visit every left node and right node for every current node. Therefore, in problems like this, that we have to visit the left node and right node and do depth first search, we always need to use a recursive function instead of iteration. If we do iteration, it will be we can get the number for every level, but it will be difficult to find the relationship between the upper level and the lower level.